So I want you to think about the last time you ordered something online. You click a button on your phone, you go about your day, and then like 48 hours later, a box just magically appears on your porch.
Right. It really does feel like magic. We're just so conditioned to that frictionless experience now.
Yeah, exactly. You don't see the ships or the trains or the massive cranes. You just see the cardboard box.
Absolutely. But behind that magic is this incredibly complex global machine. And you really don't see the friction involved in making it happen.
No, you don't. And today, we're taking a deep dive under the hood of that exact machine. We've got a really eye-opening source for this. It's PSA International's 2021 Sustainability Report, which is titled Green Horizons.
And just to establish the sheer scale we're talking about here, PSA is not like some regional logistics company with a couple of warehouses.
Right, they're massive.
Huge. They are one of the most vital gears in the entire global trade machine.
Yeah.
I mean, they operate over 60 terminals across 26 different countries.
The volume is honestly hard to wrap your head around. The report says they move roughly 250,000 TEUs, which that stands for 20-foot equivalent units, basically your standard cargo container.
Yeah, the big steel boxes.
Exactly. They move 250,000 of those every single day. Like if you line those up end to end, you're talking about a line of steels stretching from New York to Chicago.
Just in one day.
Just one day.
Which really means that any shift in how they operate is going to have a profound global impact, right? Because shipping is the lifeblood of global trade.
Oh, for sure. It connects us to food, electronics, medicine.
But it is also a massive source of emissions. The maritime industry alone accounts for, I think, about 3% of global greenhouse gas emissions.
And so that's our mission for this deep dive. We're unpacking how a colossal entity like PSA is, attempting to re-engineer itself to go green.
While also navigating some of the worst global supply chain disruptions we've seen in modern history.
Right. And ultimately, we want to figure out what that transition means for you, the listener, and the everyday goods that you rely on.
It's a fascinating technical challenge, honestly.
Mm-hmm.
Because for a company like this, sustainability isn't just good PR. It's a highly complex physical and mechanical puzzle.
Well, let's start with the big picture, because the year 2021 provides a really interesting paradox in this report. In Green Horizons, PSA states their goals pretty clearly. They committed to reducing their absolute Scope 1 and Scope 2 carbon emissions by 50% by 2030.
And hitting net zero by 2050.
Right. And actually, before we go further, we should probably define what those scopes mean for a port environment.
Sure. So Scope 1 emissions are the direct emissions. Stuff the company owns or controls.
Mm-hmm.
Think of the diesel exhaust blowing out of a truck driving around the terminal.
Okay, got it.
And then Scope 2 emissions are indirect. So that's the emissions created by the power plant that generates the electricity the port buys to run its cranes and office buildings.
Okay, so they set this massive goal to cut all of that direct burning and purchased electricity footprint in half by 2030. But then you look at the actual data for 2021 in the report, and their carbon emissions actually went up.
Yeah, by 11%.
11%. It's like deciding you're going to start a really strict diet, but you start it the week of Thanksgiving.
It's a good way to put it.
Like the intentions are there, but the environment around you is just completely hostile to the goal.
Exactly. And that 11% increase really reveals the tension between sustainability and global demand. Because the spike wasn't them just abandoning their green initiatives.
Right. They didn't just give up.
No. First off, the world was just buying more stuff. It had a 5.6% jump in total cargo volume compared to 2020. But crucially, 2021 was the year of those unprecedented COVID-19 supply chain disruptions.
Oh, man, the great supply chain crisis. Ships just waiting off the coast of California for weeks, the empty
A
shelves.
whole nightmare, yeah. And that crisis led to a very specific energy-intensive issue at the physical ports, which we can call the reefer problem.
The refrigerated containers,
Yeah.
right?
Because, a shipping container full of frozen fish or pharmaceuticals can't just sit baking in the sun.
No, definitely not.
But because of the bottlenecks, containers weren't moving smoothly onto the trucks and trains. So these reefers ended up sitting at the ports for much, much longer than usual.
And to keep the cargo cold, they have to stay plugged into the port's grid.
Exactly. They were just stranded there, acting like giant, inefficient refrigerators, guzzling electricity for days or weeks on end.
Wow, okay. So that totally makes sense why the Scope 2 emissions would spike. And looking at the data deep dive in the report, it shows that a staggering 87% of the group's entire carbon emissions come directly from the operations of their container terminals.
Yeah, driven largely by those prime movers, the trucks moving the boxes around, the massive yard cranes, and of course, the reefers.
So the problem is highly localized, right? Like,
Right.
since 87% of it is happening right there in the physical sandbox of the terminal, they essentially have to systematically redesign that entire physical environment.
Which brings us to the physical fix. Now, traditionally, port equipment runs on diesel. You need incredible torque to lift a steel box filled with 30 tons of grain or machinery.
And diesel gives you that raw power reliably.
Right, but it's incredibly dirty.
Right.
So the report highlights their transition with rotary gantry cranes, or RPGs.
And for anyone who hasn't been to a major port, an RTG is basically a colossal crane on wheels that straddles the stacks of containers. It picks them up and drops them onto waiting trucks.
They are the absolute workhorses of any terminal.
Mm-hmm.
And moving them away from diesel is just a monumental engineering task. But PSA has actually already transitioned nearly 50% of their RTGs globally to electric or hybrid models.
That's a huge shift.
And they're aiming for 90% by 2030.
I did notice, though, for the prime movers, the trucks pulling the containers around the yard, they introduced a fleet of 160 LNG, or liquefied natural gas, prime movers at their Pasir Panjang terminal in Singapore.
Yes, they did.
Now, I have to push back a little on this one. I mean, LNG is still a fossil fuel, right? It still burns, it still creates emissions. Why bother investing in a massive fleet of LNG trucks if your ultimate goal is net zero? Isn't that just sort of a half measure?
I get that, but it's really a bridge fuel. LNG isn't zero emission, but its chemical makeup means it burns much cleaner than heavy diesel. It cuts carbon emissions by an estimated 20%.
Oh, 20% is decent.
Yeah, and it drastically reduces particulate matter, like the soot and smog that really impact local air quality. You have to remember, when you're running a 247 global supply chain, you can't just flip a switch to zero-emission tech overnight.
Because the battery tech for heavy haul trucks just isn't fully there yet.
Exactly, it hasn't scaled. So you use LNG to kind of stop the bleeding while the final technology matures.
Okay, that makes sense. And if you want to see what that final mature technology looks like, you really have to look at their TUA's megaport project in Singapore.
Oh, that project is fascinating.
The report positions it as this futuristic testing ground. They're deploying automated guided vehicles, or AGVs, to move the containers, and these things are fully automated and run entirely on lithium batteries.
Yeah.
So just picture a busy terminal, but with no drivers, no diesel exhaust, just a fleet of flatbed electric robots choreographing millions of tons of cargo.
And what really stands out in the TUA's project is how they handle the life cycle of those batteries. Because, just like your smartphone, lithium batteries eventually degrade.
Right.
After a few years, an AGV battery won't hold enough charge to power a heavy vehicle for a full 12-hour shift.
And most of us just trade in our phones when that happens, but you obviously can't just toss thousands of industrial lithium batteries into a landfill.
No, you can't. So PSA applies circular economy principles here. Once the batteries degrade past the point of vehicle use, they're repurposed into battery energy storage systems, or BESS.
So they essentially build a
Giant power bank, exactly. They stack these degraded batteries together in a centralized location.
So they use them to buffer the local electricity grid? Like, if the port needs a sudden surge of power to charge a new shift of robots or plug in a bunch of those reefers, they can draw from the BESS instead of spiking demand on the city's actual grid.
Exactly, and it extends the usable life of the lithium by years.
That is such a clever piece of engineering. But I have to bring up the classic counter-argument here.
Let's hear it.
If we electrify everything, the cranes, the trucks, the AGVs, aren't we just moving the emissions from the tailpipe of a diesel truck to the smokestack of the local power plant?
Right.
Like, if the city's grid is burning coal or natural gas to generate the electricity, the carbon is still entering the atmosphere, right?
That is the fundamental challenge of electrification. An electric vehicle is only as green as the grid it plugs into.
Yeah.
But the report addresses this by detailing PSA's really aggressive investment in renewable energy generation.
Oh, okay.
They've committed 100 million Singapore dollars to tech and innovation by 2025. And a major pillar of that is generating their own clean power.
Right. I saw the breakdown for the PSA Mumbai terminal. They didn't just, slap a few solar panels on a warehouse roof. They built a full 1 megawatt ground-mounted solar farm.
Yeah, it's impressive.
Between that and their rooftop panels, they're generating 13% of their entire annual power requirements from the sun.
Which is huge.
Yeah. When you consider the massive energy demands of a major port, 13% internally generated is a massive offset.
Absolutely. And they're also investing heavily in wind and solar projects in China,
Hmm.
specifically in Tianjin and Qinzhou.
Mm-hmm.
But they aren't stopping at batteries and solar. They're actually exploring entirely different fuel vectors, specifically hydrogen.
Ah, the Hydrolog project in Antwerp.
Yes.
They ran a trial with a single hydrogen-powered terminal tractor. And I kind of want to spend a second on how this actually worked, because hydrogen isn't just like a different flavor of gasoline, right? A hydrogen fuel cell doesn't actually burn anything.
Correct. Instead of exploding diesel in a cylinder to push a piston, a hydrogen fuel cell relies on a chemical reaction. So it passes pressurized hydrogen gas through a membrane, mixing it with oxygen from the air.
Okay.
And this reaction generates an electrical current that powers the truck's motor. The only byproduct of combining that hydrogen and oxygen is water.
That is wild. The tailpipe literally just drips pure water.
Literally just water.
And the report notes that just this one hydrogen tractor in a single pilot program saved nearly 200 liters of diesel and avoided 500 kilograms of CO2 emissions.
Yeah.
If you multiply that potential across 60 terminals globally, the impact is staggering.
It is highly promising. However, fixing the physical port, the solar panels, the hydrogen trucks, the electric cranes, that only solves Scope 1 and Scope 2 emissions.
Right.
The real heavy lifting for global sustainability lies in Scope 3 emissions.
And Scope 3 is essentially everything else, right? Like the emissions generated by the massive cargo ships sailing across the ocean to get to the port, and then the thousands of independent trucking companies coming to pick up the goods afterward.
Exactly. It's the entire ecosystem that PSA operates within, but they don't legally own or directly control it.
So how do you possibly regulate emissions that aren't even yours?
Well, you manage it through data and visibility. You engineer what the industry is calling the Internet of Logistics.
Oh, I love that term. And a prime example of this in the report is their Opt-E-Arrive program. This is just such a brilliant shift in how maritime traffic works.
It really is.
Opt-E-Arrive allows approaching ships to synchronize their sailing speeds with the actual real-time availability of a berth at the port. So it enables just-in-time arrivals.
Right, because traditionally, maritime shipping operates on a Russian weight model. A ship captain might burn maximum fuel to race across the ocean, only to arrive at the destination and find out all the berths are occupied.
It's totally like driving aggressively on the highway to get to a popular restaurant.
Yeah.
You burn extra gas, you're weaving through traffic, and when you finally arrive, there's a 2-hour wait.
Yep.
So you just sit in the parking lot idling your engine. But Opt-E-Arrive is basically like joining a digital wait list from your couch.
I like that analogy.
Right. You can take a slower, highly fuel-efficient drive and pull into the parking lot exactly when your table is ready.
Exactly. And by allowing ships to optimize their speed profiles based on real-time port data hours or even days before they arrive, they can reduce a vessel's fuel consumption and carbon emissions by up to 7%.
Wow. 7% on a massive cargo ship carrying 20,000 containers represents an astronomical amount of heavy fuel oil that is simply never burned.
It's massive. That digital handshake crosses corporate boundaries to eliminate physical waste.
That's incredible.
And those collaborative efforts extend to the physical materials in the supply chain as well. For example, PSA is partnering with Ocean Network Express, or ONE, to tackle those refrigerated reefers we discussed earlier.
But not just the electricity they consume, right?
Right. They're working together to actively recover, clean, and recycle the refrigerant gases used inside the cooling systems of those containers.
I really want to highlight why this is so critical. We talk a lot about CO2, but refrigerant gases, these synthetic molecules used to absorb and transfer heat, they are extremely potent greenhouse gases.
Oh, absolutely.
Like, if they leak into the atmosphere, their molecular structure makes them exceptionally good at trapping thermal radiation from the sun. Some of these gases have a global warming potential thousands of times greater than carbon dioxide.
Which means a small leak in a reefer unit can do the atmospheric damage of a dozen cars driving for an entire year.
That's terrifying.
Yeah. So PSA and ONE are actively ensuring that when reefers are serviced, that gas is carefully captured, certified, and pumped back into repaired units instead of just venting into the sky.
It really requires looking at every single chemical process and material, and the report reveals they're even changing the ground they walk on.
Yeah, at the 2S Megaport project.
Yeah, right. They're replacing ordinary Portland cement with something called granulated blast furnace slag, or GGBS, for their civil infrastructure.
Because the production of standard cement is one of the biggest biggest hidden sources of global emissions. It accounts for roughly 8% of the world's CO2.
Because of the calcination process, right?
Yes.
When you make traditional cement, you take limestone and heat it to extreme temperatures in a massive kiln. But limestone is calcium carbonate. When you apply that heat, it forces a chemical reaction that splits the rock into calcium oxide, which you need for the cement, and carbon dioxide, which just releases into the air.
You're essentially baking CO2 directly out of the stones. It's unavoidable if you use limestone.
Right. And ground granulated blast furnace slag bypasses that entirely because GGBS is a byproduct of the steel manufacturing industry, right? It's the slag left over from iron ore refinement. It's
Exactly.
kind of like using the leftover bones from a roast chicken to make a rich broth instead of raising and boiling a brand new chicken.
That's a very vivid analogy, but yes, exactly. Right. You're taking industrial waste that already exists and repurposing it to skip the resource-intensive step altogether.
And the carbon savings are immense. By swapping out traditional cement for GGBS, PSA achieved over 53,000 tons of carbon savings just in the first phase of the TUIS project.
They're literally rebuilding the foundations of the port with a lower carbon footprint.
Okay, so we have a massive deployment of technology here. We've got the electric cranes, hydrogen tractors, the lithium batteries buffering the grid, digital wait lists for ships, and recycled steel slag replacing concrete.
It's a lot.
It is a lot, but there is a glaring blind spot in treating this purely as an engineering problem. This entire global system is still operated by people.
Over 42,000 employees globally.
Right. So how does a corporation of that size bring tens of thousands of workers along for this massive operational pivot? Like, you can mandate that a truck runs on hydrogen, but you can't just mandate a culture shift.
No, you can't. It requires really deep workforce engagement. And the report indicates they're taking this seriously. I mean, they saw a 94% participation rate in their global employee opinion poll.
Anyone who has ever worked in a corporate environment knows that getting 94% of your staff to fill out a survey is almost statistically impossible.
It really is.
That shows a highly engaged workforce.
It does. And it yielded a 79% satisfaction rate. But, engagement isn't just about surveys. It's about equipping the workforce for the new reality. So PSA developed an e-learning program called Greenfish Climate Action to educate their staff.
The goal is to make their employees actually fluent in the mechanisms of sustainability so that a crane operator or a logistics manager on the ground understands why a new procedure is being implemented rather than just treating it as, another annoying corporate rule.
Right. Knowledge is most valuable when it's understood and applied by the people physically doing the work. And the report also details how this sense of responsibility extends outward into community resilience.
Yeah, they contributed 750,000 Singapore dollars to 110 different charities. One example that really stood out was the staff at the Ashcroft terminal in Canada.
Oh, during the wildfires.
Yeah. When massive wildfires hit British Columbia, the employees there utilized port resources to provide disaster relief for evacuees in their surrounding community.
Because a sustainable business cannot exist in a failing or vulnerable community.
Exactly. But I want to pause here for a second because it is very easy to read a glossy corporate sustainability report, highlight the charity donations and the e-learning modules and just pat everyone on the back.
Right.
But let's look at the gritty reality. Ports are intense, dangerous, heavy industry environments. What does sustainability mean when you're dodging 30-ton steel boxes swaying on cables?
That is the most critical question to ask when reviewing a report like this. You have to look at the safety metrics. And there is a very sobering statistic in the 2021 data. Amidst all this technological progress and emission reduction, there were 3 fatalities across their global operations.
3 lives lost.
Yes. The incidents involved an employee, a contractor, and a third-party worker. And it really makes you question our assumptions about what the word sustainability actually encompasses.
Yeah.
Because true sustainability isn't just about counting carbon molecules or tracking kilowatts. It is fundamentally about the preservation of human life and occupational safety.
If the people running the machines aren't safe, the carbon footprint of the machine is kind of irrelevant.
Exactly. And the report rightfully tracks safety metrics directly alongside CO2 emissions. They monitor the lost time injury frequency rate, which it did drop to 2.94 in 2021.
Okay, that's good.
It is. But recording those 3 fatalities proves that protecting workers is step 1 of stewarding a responsible business. You cannot claim to be building a better, greener future if the people physically building it are at risk.
That really grounds the entire conversation. I mean, it's so easy to get lost in the excitement of automated robots and hydrogen fuel cells, but the transition to a green global economy is messy.
Very messy.
It involves massive heavy machinery, it's inherently dangerous, and it requires constant human vigilance.
It's a massive ecosystem in transition. They're balancing the immediate demands of global trade with the long-term survival of the environment and obviously the safety of the workforce.
Which brings us back to where we started today, the massive juggling act that a company like PSA is attempting. I mean, they are trying to slash emissions in half while processing a massive surge in global cargo volume, managing the fallout of pandemic supply chain grids, testing untested future fuels, synchronizing ship speeds across oceans, and trying to ensure 42,000 people make it home safely at the end of their shift.
The scale of the challenge is matched only by the scale of the necessity.
Absolutely. So for everyone listening, the next time you click Buy Now from your couch, remember that the magic of that cardboard box isn't magic at all. It is a massive, gritty, global choreography of hybrid cranes, digital waitlists, alternative fuels, and tens of thousands of workers springing into action just to get that item to your door.
We've talked a lot today about data visibility, right? The Internet of Logistics tracking carbon across the globe so that shipping lines and ports can optimize their behavior. But let's connect this directly to you, the consumer. What if, in the near future, that data visibility is passed all the way down the chain to your phone screen?
Oh, that's interesting. What would that actually look like in practice?
Imagine if the online price tag on a pair of sneakers didn't just show the dollar amount. Imagine if, right beneath the price, it displayed the exact carbon cost of manufacturing those shoes and shipping them across the ocean through these exact ports directly to your zip code.
Wow.
If you could see the hidden environmental price tag of global logistics in real time right there at checkout, would it change the way you shop?
That is a great question to end on. Right now, the magic of next-day delivery hides the machinery. But if that curtain is pulled back, the magic disappears, and every single one of us has to face the reality of the machine.